This is the second video in a series of videos on how to use Google Test in Visual Studio 2012. In our first video, we created a solution that had 3 projects. The first project was the project that we are trying to test. The second was the Google Test project, which contains a static library for Google Test. And the third, a Bitcoin unit level test. That's where we're going to store our unit level test. In this video, we're going to learn about the test macro, come up with a good naming standard on how to name our test case names and test names, and then how to use assert and expect to look for conditions for our test to pass. Let's go ahead and get started. So the first thing we need to do is we need to recognize what we're going to test. So typically we write a test case corresponding to an individual class. In this case, let's select the Bitcoin transaction class. It's a simple class, made for a good example. Next thing we need to do is select the unit level test project and hit right mouse click and then go to add new item. Here we want to add a CPP file, and we want to name that file something that is easy for us to identify that it's a unit level test for Bitcoin transaction. I follow the naming standard that names it just like that, Bitcoin transaction ULT. That way I know it's a Bitcoin, all the Bitcoin transaction ULTs are in this file. Let's go ahead and hit add. The next thing you need to do in this CPP file is include the Google Test header file. It's googletest/googletest.h. That gives me access to the test macro, expect, and assert macros. The next thing I want to include is the actual Bitcoin transaction header file. That's what I'm going to test. So I need to make sure I include it so I can see the methods inside that header file. Before we write our first test, let's explain a little bit about the macros. The test macro is contained in gtest.h, and it takes 2 parameters, a test case name and a test name. You can think of this as a test case contains a set of tests. So before I type in a test case name, let's look at some naming standards that may benefit us from using. So one thing that's important is that you do have some kind of standard. It's really hard to find the information when you have hundreds, if not thousands, of tests that are running and test case names where a standard isn't used. And if you could have name collision for test case names and all that. So it's best to come up with a standard and stick to it. So the one that I like to use is pretty simple. My test case name is the name of the class that I'm testing. And the test names follows this pattern, the method name and the condition that I'm testing in that test. So method name and condition. For example, add money is the name of the method, and I'm going to add a positive amount. Or add money and I'm going to add a negative amount. And then my test will test for those things. So let's go ahead and write one of these and you can see what it looks like. So the first one I'm going to write here is Bitcoin transaction is the test case name, and the test I want to write is set, and then I'm going to say good values. So I have my first test. Doesn't do anything yet. So now I need to use the other macros, assert and expect. So let's take a look at how we use those. So assert underscore can be followed by true, false, EQ for equal, NE for not equal, and then your standard less than, greater than, less than or equal to, or greater than or equal to. Inside that macro, you'll put your conditions for true and false, and for equal and not equal, you put an expected value and the actual value. What's important about assert macros is when an assert fails, it will exit the function at that time. It'll exit that test macro at that time. It won't run any additional code. This is really good when you're checking for pointer functions, or you're checking for pointers, making sure they're valid, all those things. It's a nice, quick, dirty way to fail immediately instead of running a bunch of code. Just like assert, we have expect. Expect, although it fails, it does not actually exit the function at that time. It will continue to run the next ones, but your test will fail anyway. This is good if you want to continue to test things beyond one condition failing. It'll exercise more of the code. So let's see practically how this can be used. So let's come up here and let's type this in. Okay, so the first thing I do here is I create a Bitcoin transaction object and I run an assert command. This assert tells me it will fail and exit the program here if BT pointer is not equal, if it is equal to null. So it says assert not equal Bitcoin transaction pointer null pointer. So if it is a null pointer, it will assert. This method call right here to the Bitcoin transaction is setting values inside the Bitcoin transaction, and then I am calling expect to see if those values are actually set appropriately. So in this case, I used one assert for not equal and two expect macros with equal. Let's go ahead and run this now. Now the best way to run this is to use Control F5. But in order to use Control F5, you need to make sure that you have Bitcoin unit level test set as your startup project. If you don't do it, then it won't actually run your unit level test. So let's go ahead and hit Control F5, and it's going to build this unit level test and then go ahead and run it. So there it's compiling Bitcoin transaction unit level test, and it's kicking off running the test itself. You'll get some output just like this. So you can see in here it's fairly easy to write a test, and I've tested just that part of the code. Let's go ahead and add another test. To add another test, I can add it right in this file. So let's add another test here, but instead of good values, let's change this to bad values. So let's put in a -2000 and a -100. Now you would think that you can't transfer negative money. Let's see what happens when I try. Go ahead and save this, and again I hit Control F5. Compiles the unit level test and then goes ahead and runs it. Oh, I got a failure this time. That's exactly what I would expect, right? So what I want to do is change my test. Let's change our test to say, no, that shouldn't equal 2000. That should equal, let's say, not equal to 2000. Say not equal to 2000 or to 100. Now let's go ahead and run it. And now my test should pass. Now it's not a very good test because ideally my Bitcoin transaction should never let me set to a -2000. But in this case, it does. But I'm not here to fix the code. I'm here to write tests right now. Okay. In our later videos, we'll show you more on how to use the test macro and more asserts and expects, especially with exception handling and with some nice add-in tools for Visual Studio so you can see the results directly in the IDE. Check out our next videos.